Hi everyone, let us talk about the lab exercise entitled SALTS. Part 1 of the experiment is about properties of starting materials, where the starting materials that we are talking about is ammonium hydroxide and acetic acid. The setup involves placing the material on a watch glass, which in turn is placed on top of a beaker with boiling water. Now, since ammonium hydroxide and acetic acid are volatile materials, then after the heating period of about 5 to 15 minutes, nothing is left on the watch glass. Now, when 5 drops of the acetic acid is placed on a watch glass and added with 5 drops of ammonium hydroxide, they are placed together and they are also evaporated to dryness on a water bath. What happens to the mixture? Now, since acetic acid is acid and ammonium hydroxide is a base, then there will be an acid-base reaction, or this is called neutralization. Okay, so this will be neutralization reaction where you produce ammonium acetate and water. So, since it is now producing a salt as product, then it will leave behind a residue after the mixture was evaporated to dryness on a water bath. Ito sa number 1, letter A, where you have acetic acid only heated on a watch glass, it does not leave any residue. Letter B, likewise, since ammonium hydroxide is also volatile, it does not leave any residue. But together, acid and base will form salt and water. This is not volatile while water is volatile. So what is left behind after heating or after evaporating to dryness is salt, ammonium acetate. Okay, so that answers the question, what happens to the mixture, what are the equation involved, what is a salt? What is a salt? Any chemical compound formed from the reaction of an acid with a base. Of course, there are other ways to produce salts. So we don't limit ourselves with reaction of acid with a base, because there are other procedures where you can produce salts. Is there a difference in the properties of the product obtained and the starting materials? Yes, there is, because the starting materials or the reactants were volatile, but the product, particularly itong ammonium acetate, was non-volatile. Now, what would happen if 1 or 2 drops of acetic acid is added in excess, or 1 to 2 drops of ammonium hydroxide is added in excess? What would happen? Now, knowing that they are volatile, any excess of the volatile acid or base will be evaporated after heating, after evaporating to dryness. So nothing will happen to the product after evaporation. Kaya volatile man yung acetic acid, volatile din yung ammonium hydroxide. So after heat evaporating to dryness, lilipad din itong acetic acid at ammonium hydroxide. Okay, so this is preparation of salt. This is another way where you produce a salt by the action of an acid on another salt. A piece of calcium carbonate in a test tube is added with acetic acid. What did we observe? Production of bubbles. That bubbles is carbon dioxide. And the product is calcium acetate. Okay, we decanted the supernatant into an evaporating dish, and the supernatant is heated to dryness. This is the product. This is a white salt. This will be the one left in the evaporating dish. Another way to produce salt is by the reaction of two other salts. Sorry. Sorry. Okay, so in this case, ang involved na salts are potassium chromate and barium chloride. Okay. If they are mixed together, they will form a yellow precipitate barium chromate. And the one that is the other salt that is left in solution is potassium chloride. So yung barium chromate will be the yellow precipitate. Next is preparation of salt by replacement or single displacement. So this involves copper sulfate solution and magnesium ribbon. Now, I'd like to share with you a video. Magwo-work kaya ito? Uy, ayaw. Ayaw mag-work. How do I make it? Ayun. Okay. Okay. So initially, you see that the solution is blue. Now, after standing for 2 days, ito na yung nangyari sa kanya. Okay. Meron pang reaction, no? Makikita nyo. Meron pang reaction. But what is observable is the disappearance of the blue color. Naging colorless na ito. So this portion is decanted into an evaporating dish. What else do we observe? Brown deposit, brown product. Ayan o. This is copper. Tapos, this portion is evaporated to dryness, yung supernatant. Take note, colorless na siya, wala na siyang blue. Ibig sabihin, naubos na yung copper. Kasi yung color ng copper ay, in solution is blue. Okay, so this is the balance equation. Copper sulfate, which is blue at the start, with magnesium ribbon. Copper will deposit as brown deposit, and what is left in solution is magnesium sulfate. Okay, if you evaporate the supernatant in an evaporating dish, this will give you a white residue, magnesium sulfate.